Welcome back, guys. Here's another example that's very common for AP, and this is one where you have two masses that look like they're in the same exact situation. So one of them is on a rough surface with a mu of zero point 0.2, and it's feeling a force down of 50 newtons. The second one is also on the same rough surface, has the same mass, but now instead of a 50 newton force down, it has a mass of 5 kilograms pulling it down, which would have a weight of 50 newtons. So let's look at this. So case one, calculate the acceleration of the 10 kilogram block in case one. So the forces on the 10 kilogram block. It's going to have friction going that way. It's going to have tension going this way. It's going to have normal going that way. It's going to have weight going down. And I'm going to say that this is probably longer than that because I would assume that it's accelerating to the right and not to the left. I need to find the normal because I need to find my force of friction. So in the y direction, fnet is equal to 0. So I take my forces up minus down. So this is going to be n minus mg. So n is equal to mg, and that's going to be 10 kilograms times 10 meters per second squared, or 100 newtons. All right, so now I'm going to calculate my friction, which is going to be equal to mu n because it's a sliding friction. So this is going to be 0.2 times 100, which is going to be 20 newtons. All right, so now I'm going to do my x direction. In the x direction, fnet's going to be equal to ma. I'm going to take my right minus my left, and so that's going to be t minus f equals ma. So a is going to be equal to t minus f over m. So my tension was 50, my friction is 20, my mass is 10. I'm going to have an acceleration to the right of 3 meters per second. I'm going to pause for. All right, guys, I'm back. I'm not alone anymore, so I'll be masked. On the diagrams below, draw and label all the forces acting on each block in case 2. So again, I said this is going to look like it's the same case, but it's not. I'm going to call this M1G and N. I'm going to call this F and T. This is going to be the same T, but this is going to be a different mass. So I'm going to call that M2G. Calculate the acceleration of a 10 kilogram block in case 2. All right, so these two things look the same. They look like there's 50 newtons of force that's acting on this 10 kilogram block. So you would think that it's going to be 3. It's not. First off, this is a pulley problem, so I am going to make forces that turn the pulley counterclockwise to be positive. I'm going to start with the 10 kilogram block. And I'm going to say that fnet equals m1a. I'm going to take counterclockwise minus clockwise. So this is going to be f minus t equals m1a. Now again, the normal is going to be the same from the first problem, and the mu is the same from the first problem, so our friction is still going to be 20. So I have to solve for that again. I'm also going to have an fnet for this one, which is going to be m2a. And so now I'm going to have t minus m2g equals m2a. because this T would turn the pulley counterclockwise. This M2G would turn it clockwise, so that's going to be negative. What am I going to do? I'm going to add these two together. And so when I have F minus T equals M1A, and T minus M2G equals M2A, the T's are going to cancel, and I'm going to have F minus M2G equals M1A plus M2A. I can factor out A, so I'd have M1 plus M2 times A, and I can divide by M1 plus M2. So I'm going to have F minus M2G over M1 plus M2 is A. So again, this is going to be 20, because we solved for the friction previously. The mass of M2G is going to be 50. And then M1 is 10, and M2 is 5, so that's going to be 15 kilograms. So this ends up being negative 2 meters per second squared. This just tells me that I have a clockwise turning of my pulley. So you can see, even though we have the same net force in both of them, this net force is only accelerating 10 kilograms, where this net force has to accelerate 15. And some of that force needs to be used up to accelerate that one. Right, so this was 1979, number 2.